classes record हुने गरेछ. Okay. So have we got reduction formula for this IN?
Yes, ma'am. Ma'am, यसको यो definite पनि दिएर चाहिँ कि pi/2 सम्म गरे हो गरे cos को.
This one. यहाँसम्म फाइन्ड आउट गर्यो होला हामीले हैन, यहाँसम्म भयो होला हाम्रो.
अनि म्याम यो बुकमा हेर्दा यो भन्दा अगाडि चाहिँ यो के रे डिफरेन्स इन्टिग्रेसन अन्डर डिफरेन्सियल साइन हो कि के पो भन्ने थियो म्याम.
त्यो टपिक हामी गरौँला, पछि गरिन्छ.
सिलेबसमा चाहिँ छ म्याम त्यो.
सिलेबसमा छ, हाम्रो कोर्समा भएको कुरा केही पनि छुट्दैन हैन. त्यो टपिकमा चाहिँ के छ, सल्युसन्स अलि हल्का लेन्दी छ. तिमीको इन्टिग्रेसन गर्नु भनेकोलाई डिफरेन्सिएसन पनि गर्नु छ, फेरि इन्टिग्रेसन गर्नुपर्छ ट्वाइस or 3 times you have to integrate. So process becomes slightly lengthy, although it's easy. तिमीले एउटा कन्सेप्ट बुझिसकेपछि it's not going to be difficult, but त्यो अलि लेन्दी चाहिँ जान्छ. त्यही भएर मैले त्यसलाई चाहिँ अलि पछि गर्न खोजेको. It's up to you if you want to do it first, then we can do it next week. आजलाई त रिडक्सन फर्मुला सुरु भएको छ, we have to complete this. Now what do you say?
हुन्छ म्याम, यही कन्टिन्यू गरौँ न अहिले.
यो त कन्टिन्यू गर्नु पर्यो. फेरि तिमीले अरु टपिक्स गर्नु भन्दा अगाडि त्यही टपिक गरेर मात्रै गर्ने भन्यो भने we will do that next time. Okay?
जोताबाट जसरी लगे नि हुन्छ हजुरले.
त मैले चाहिँ के भन्दै कि तिमीलाई सिलेबसमा छ तिमीको सिलेबसमा छ, त गरिन्छ. I forget to mention that. मैले भन्नुपर्ने, मैले बिर्सेको छु. सिलेबसमा छ, अरु सबै कुरा सिलेबसमा छ है. अगाडिको सबै पोर्सन छ, नभएको त्यो एउटा पोर्सन मात्रै है. Okay, so maybe last time we have got this part only. अनि यसपछि हामीले we calculated J10, how to use it. Have you seen this part? यहाँ पावर 10 राखेर cos को पावर 10 राखेर हामीले हेरेको थियो कसरी गर्ने. Come on.
Yes ma'am, हेरेको थियो यो.
Okay, so के आउँछ roughly, let me do it है. अहिले स्पिड मा 9/10, 7/8 and so on हैन. But यो यसको फाइनली के आएको थियो, let's just write it down. 5/6, 3/4, 1/2 and finally के थियो J0 आउँछ हैन. यसपछि J0 and what is J0? हामीले रिडक्सन फर्मुला युज गरे सकेपछि finally we will get J0. What is J0?
pi/2.
Yes, cos to the power 0x dx, 0 to pi/2. So cos to the power 0 means 1. So you have to integrate just 1. One line integration गरेर apply limits of integration, you will get in place of this you will get pi/2. Okay, so why are we calling this reduction formula? Did you realize? You see, we are keep on reducing our value of n. सबभन्दा पहिले J10 छ, J10 पछि reduce भएर J8 आउँछ and then J6, J4 and so on. At the end you will stop your process when you will get either J0 or J1 हैन. नेगेटिभ मा यानी हैन, J0 आयो भने क्याल्कुलेट गर्न सकिन्छ, J1 आए पनि क्याल्कुलेट गर्न सकिन्छ. So we will stop when we will get J0 or J1. Okay, so in this case your n, let's observe there are two cases. In this case your n is even. N is even, that's why when you were processing, when you were reducing your n values of n and looking for your J10, what have you got at the end? J0. J0 किन आयो? Because your n is even, because each time you are reducing it by 2. इसको value each time you are reducing it by 2. तो even छ भने reduce गर्दै गर्दै finally केमा पुगिन्छ? J0. Okay, what if it is odd? Now let me ask you, what will be your yes? What will be your finally J suffix? when n is odd?
J1.
Yes, exactly, J1. So you will stop your process when you will get J1. Okay, so let's just give an example. Suppose we are calculating J7. Okay, J7 calculate गरिरहेको छ भने let's use this reduction formula. यो reduction formula use गर्नु पर्यो. For calculating J7, put value of n equals to 7 first. What will you get? 6 by 7, J5. Yes, J5. And what is the J5? What is the J5? J5 will be put again value of n equals to 5 here. You will get J5 equals what? 4 by 5 J5 and J3 आया. Okay, and then again what is J3? What is J3? J3 will be 1 by 2 by 3 J1. Okay, so you will stop when you will get 2 by 3 J1. So तिमीको final expression यो भयो 2 by 3 J1. Okay, so finally you got J1. What is J1? What is value of J1?
Cos F.
Really?
1 हुन्छ.
1.
Yes, it's 1. Okay, you have to keep this in mind that your J1 sir, it's a definite integral. The तिमीको answer constant मा आउनु पर्यो. So what is J1? J1 means, what is J1? It means 0 to pi by 2 cos x dx, cos the power 1 dx. So when you calculate this, we have already done this integral many times. हामीले first topic देखि नै धेरै चोटि यसको integration गरेछ and we got the result equal to 1 हैन. So J1 को value equal to 1 छ. So it's equal to 1. So you can replace this value by 1. Okay, so finally what's your result? So finally your J7 is equals to 6 into 4 into 2 divided by 7 into 5 into 3 into 1. So it doesn't matter. Okay, so that's your answer. So we have two cases. Now let's write down reduction formula for two cases. First case is when your n is even. Second case is when your n is odd. So what is the pattern for your Jn? How your Jn will change? It depends on both the cases when n is even. Even हुँदा फेरि के हुन्छ? How are you going to begin your you see तिमीको final result के छ? Your final result is like this. If n is even, 9 into 7 into 5 into 3 into 1 divided by 10 into 8 into 6 into 9, 4 into 2 into pi by 2. Always, whenever your n is even, always your final value will be pi by 2, and pi by 2 is यहाँ सुरु यससँग multiplied के terms 1 by 2. So यो तिमीको terms are reduce हुँदै जान्छ. Finally you will stop when you will get 1 in the numerator, and in denominator you will stop when you will get 2. Okay, so beginning से कहाँबाट गर्ने? Beginning depends on value of n. n को value में depend गर्छ. तिमीको n 10 छ, त्यही भएर यहाँ 9 by 10 बाट begin भयो. When if it is 12, then you will begin like 11 by 12. If it is 20, 19 by 20, and so on. Okay, so it depends on your n. So what will be your Jn if n is even? Can you tell me?
n minus 1 divided by n into n minus 3 by n minus 2 अनि गर्दै जानी अनि 1 by 2 into pi by 2.
Very good. Each term is reduced by 2, isn't it? Yeah, 9 छ, त्यसपछि 7 छ, त्यसपछि 5. So each term is subtracted by 2. Okay, so numerator मा सबभन्दा पहिलो term के छ? n minus 1. You see n minus 1 छ सबभन्दा पहिला. numerator ma n minus 1. So you have to begin from n minus 1. यहाँ 27 and 19 बाट सुरु गर्नु पर्यो numerator. यहाँ 24 छ भने 23 बाट तिमीको numerator सुरु हुने भयो multiplication. 24, 22, 20 and so on. Okay, so it depends on your n. So let's keep on moving like this. Keep going. And when will you stop numerator? When you will get 1. And denominator चाहिँ कहाँबाट सुरु हुन्छ? n देखि सुरु हुन्छ हैन? n देखि. And our each value will be subtracted by 2. So on, and finally your multiplication will be by 2. Okay, and multiplied by pi by 2 always when your n is even. So हाम्रो यो even को case भयो j10. So we have seen that we will finally get pi by 2, and numerator ma final value will be 1, denominator will be 2. Okay, and starting depends on your n. So any doubt in this case? Anybody who wants to who want me to repeat this? Yes, no doubts. Okay. So next is when your n is odd. So we have just seen when are we going to stop? J1 आए थे हाम्रो finally अनि J1 लाई हामीले कसले replace गरे थे 1 लाई. So your value numerator को last को value will be numerator मा last के सँग multiply हुने भयो 2 सँग, denominator मा last multiplication will be 3 and J1. So J1 will be replaced by 1. So we need not to write it down. So what will be your starting point? Again same n minus 1 over n. And starting point त त्यही नै भयो नि numerator र denominator को लागि, because here we have 7, so 6 by 7 भयो first term. If it is 17, then we will have 16 divided by 17 and so on. So it depends on n again. So what will be your Jn for n odd? So when your n is odd, your Jn will be, beginning will be same, n minus 1, n minus 3, so on, and final term from your numerator will be 2, and in denominator your final term will be 3. Isma n minus 2, so on, and final term will be 3 and multiplied by 1. So I'm not going to write it down. It's obvious that we will get J1 at the end. So this is your Jn for n when n is odd. Yes, anything that needs to be repeated? Any doubts? No. So then let's look at one more. Okay, so we have done in a reduction formula for cos x. You go through your books, you can similarly find out reduction formula for sin x. Yes, very important question. Let me ask you one thing. यो जुन Jn हाम्रो आयो नि, Jn means you all know 0 to pi by 2 cos to the power n x dx. Can you tell me what changes you are going to make in reduction formula such that you are going to get reduction formula for sine to the power nx? I'm talking about when you have limits of integration 0 to pi by 2. Okay. Can you, on the basis of this, can you tell me what will be your reduction formula for sine to the power nx dx with limits of integration 0 to pi by 2? Limit of integration same छ. त यहाँ चाहिँ हाम्रो reduction formula कस्तो आउँछ for cos sine if cos is replaced by sine? Can anyone tell me? Just give it a try. Think about it.
त्यही आउँछ.
How
Sine
can
को
you say
power
this?
n minus
Yes,
1
Vivek.
x cos x by n. Sine को power n minus 1 x cos x divided by n अनि n minus 1 by n in minus 2.
What are you saying?
होइन त्यो डिफाइनाइट इन्टिग्रलको प्रपर्टी लगाइदिने हुन्छ होला नि म्याम
Yes, that's what I was willing to hear. Timoko solution, one of you have mentioned ki Timoko, your solution will be exactly same. Yes, true, because you know you apply properties of definite integral. When you replace your x by pi by 2 minus x, cos x, your cos x will be replaced by sin x, or sin x will be replaced by cos x. Cos x is sin x, sin x is cos x. So you when you use properties of definite integral, I'm glad that you gave correct answer. You were able to mention this. Because of properties of definite integral, property number 4, you can say that this integral is equal to this. Okay, so the reduction formula will be same now, but keep this in mind. You say hamro kun case ma matre bhayo when you have limits of integration 0 to pi by 2. Timerko definite integral ko case ma bhayo hai. This thing will not be same for indefinite integral. Indefinite integral ko case ma it is going to give you expression. That expression will be somewhat different. Okay, so to expression kasari find out garne, you are going to follow same process. Okay, same process. Yeah, sine ko ठाउँमा cos ko ठाउँमा sine भयो भने you are going to break it again like this, sin x into sin x to the power n minus 1. Then you will apply integration by parts, and you will finally get this reduction formula, this expression. Okay, this expression. So it is already done for you by your textbook. You can go through it. Okay, so examples ma dekho sa. So just go through it. Now let's look at this part. Now this is slightly different. Okay, तिमीको 10x को लागि sec x को लागि cot र cosec x जुन बाकी छ त्यसको लागि to find out reduction formula, your process will be somewhat similar to this one, 10 to the power nx dx. Okay, अहिले हामीले sin x र cos x लाई हेर्यो last time. अब चाहिँ बाकी remaining 4 functions को लागि. Okay, so suppose we are calculating for 0 to pi by 4 अनि question मा तिमीको I5 calculate गर्नु पनि भनेछ. So question says find out reduction formula for this expression 10 to the power nx dx अनि यसलाई हामीले के नाम दियो in with limit of integration 0 to pi by 4, and finally calculate your I5. Okay, so here you don't have to be confused. यहाँ चाहिँ in को symbol को meaning के हो, you can clearly see that. Okay, mute yourself. कसको यो unmute भएको छ, mute गरौँ. Okay, so you can clearly see here. Next, what are we going to do? We are going to again break it like this. Okay, here cot x भएको भए पनि you could have done cot to the square x cot to the power n minus 1 n minus 2 x. Okay, like this in the same way. Okay, so हामीले यसरी break गर्न मिल्यो integral लाई. Now you can replace this 10 square x by sec square x minus 1. Next step, sec square x. Now we have we are dividing this breaking this integral into two parts in this way. हैन, दुईटा parts मा divide गरे integral लाई. So your first term will be sec square x 10 to the power n minus 2x dx. Okay, second part will be 1 सँग multiply भएर के आउँछ 10 to the power n minus 2x. Okay, so what is this? What is this?
in minus 2.
Very good, in minus 2. Okay, so we will keep it as it is, in minus 2 राख्ने अब यसलाई चाहिँ. And let's look at this part. How are we going to deal with this? Can you tell me what is differentiation of 10 to the power n minus 1x? Let me ask one of you. Ayush, Sapkota. Ayush class. Okay, yes, Ayush Thakuri. How do you differentiate this? I'm unable to hear you straight. Yes, Ayush Sapkota. Yes, how do you differentiate this? What is differentiation of 10 to the power n minus 1x? We have Anuj. Yes, Anuj.
Yes, ma'am.
How do you differentiate this? इसका differentiation क्या होगा?
N minus 1, 10 to the power n minus 2x upon 1 plus x square.
Okay, very good. Can you repeat it? My last को अलि miss गरे जस्तो लाग्यो. You said in the beginning n minus 1.
N minus 1, 10 to the power n minus 2x upon 1 plus x square.
Upon 1 plus x square.
Yes, ma'am.
Really?
No. Sec square x.
Very good. Sec square x. Okay. So तिमीको के भयो यहाँ? What will you get? You will get sec square x here. Okay, so this into dx, let's write down dx also. Okay, so this is your differentiation of 10 to the power n minus 1 x. Now, why we are discussing this? Now let's relate. Look at this expression. What do you see here? You see, we have sec square x 10 to the power n minus 2 x dx. And isn't this exactly similar to this? 10 to the power n minus 2x sec square x dx. So you do the term this exactly same way, I know. So this can be replaced by this term can be replaced by d to the power derivative of 10 to the power n minus 1 x divided by n minus 1. Yeah, n minus 1 फाल्तु भयो नि. यसलाई अर्को साइड लिएर जानु पर्यो. So divided by n minus 1. Okay, so you can see here in next expression, I've written 1 over n minus 1. n minus 1 कहाँबाट आयो? From here. Okay, 1 over n minus 1. And in place of this is ठाउँमा derivative of 10 to the power n minus 1 x. Okay, with and your integration includes limits of integration from 0 to pi by 2. Now, how do you integrate this part? What is integration from 0 to pi by 4 derivative of 10 to the power n minus 1 x? Can you tell me? What will you get from this expression? Quickly.
10 to the power n minus 1x नै हुन्छ.
Yes, very good. Okay, so when you integrate integration and differentiation, यहाँबाट के हुन्छ तिमीको integration र differentiation cancel out हुन्छ. Integration and differentiation gets cancelled, and 10 to the power n minus 1 x के यति मात्र sufficient छ? Is it sufficient?
Limit of integration, ma'am. 0 देखि pi by.
Yes. How can you forget that you have definite integral? So this is your function of integration. Integration गरिसकेपछि हाम्रो यो function आयो. अब यसमा you have to apply limits of integration 0 to pi by 4. You have limits of integration 0 to pi by 4. So apply it, and what will you get? When you integrate this, what will you get?
1.
Yes, exactly. Upper limit will give you 1.
1.
Lower limit gives you 0. Okay, so 1 minus 0, 1. So from first expression, you have just got 1 over n minus 1, and you are left with minus I n minus 2. So this is your reduction formula for this one. Okay, so you have got your reduction formula. Now you have to use it for I5. Can you calculate it right now or just do it? You can do it later. I'm leaving it here. Okay. I'm not going to continue now. You know how to use a reduction formula. Is there any doubt? Can you use it? Okay. Do you want to do it right now? Just calculate and give me I5. तिम्रो question I5 पनि calculate गर्नु भने चाहिँ calculate for your I5. Quickly, all of you, I can ask anyone. Calculate your I5 using your reduction formula. This is your reduction formula. Yes, who will tell me? Yes, Anup, will you tell? Anup, will you tell? Not listening.
Yes, ma'am.
Have you got the result? Calculating. Yes, Anil Chaudhary.
Yes, ma'am.
Have you got the result?
Ma'am, 3/4.
3/4.
Mistake.
Mistake
does not exist.
No, it exists.
1/2 log 2 minus 1/4.
Yes, very good. Arun Subedi, calculate गरेर भनेको हो कि बुकबाट सल्युसन हेरेको?
Calculate garega, ma'am.
Very good. Okay. So rest of you also आयो?
Yes, ma'am.
Minus
Aye.
1/2 plus log 2.
1/2 log 2 minus 1/4. Okay. So if you haven't got this answer, then calculate it again. So now let's go for one topic which is related to this. यसैसँग अझै एउटा टपिक के छ, your beta gamma function. So where is it?
Ma'am, यो exercise बाट question चाहिँ कस्तो सोध्छ?
तिमीको मैले yes, यस्तै नै सोध्छ, find out a reduction formula for this expression and hence find the value of this भन्छ. जस्तो मैले भर्खर हामीले हेर्यौं नि, find out reduction formula for 10 to the power nx dx with limits of integration 0 to pi/4 and hence calculate I5. So तिमीलाई पहिला reduction formula find out गर्नु भन्छ अनि त्यसपछि calculation एउटा number देला I5, I4 whatever and then you have to calculate. Okay? So first, second, third questions are this similar questions are also beta gamma function. Okay, so very important topic, very important, beta gamma function. Okay, very interesting also. Now you have to keep these integrals in mind. Okay. your mathematicians realized that there are few integrals which are very important, which are very significant. Okay, so the duita तीन integrals मध्ये दुईटा integral के भयो beta function and gamma function. So it has many applications. तिमीहरुको now because today you will be introduced to beta gamma function. तिमीहरुले एकचोटी introduction भइसकेपछि you are going to use it in future studies भनौं न अब further studies गर्दाखेरि या फिर further तिमीले topics हरु हेर्दाखेरि you will be using it many times. Okay, so beta function and gamma function यो in our integrals special भएको भएर यो integrals हरुलाई हामीले नाम पनि दियो. Okay, so symbol पनि दियो नाम पनि दियो. So beta function and gamma function. So which one is your first integral? Your first integral you can see is this. Okay, 0 to 1. Okay, x to the power m minus 1 and 1 minus x to the power n minus 1 dx, where m comma n are certain value greater than 0. Okay, not equal to 0, greater than 0 हुनु पर्यो, 0 हुनु भएन. Okay, so for m and n greater than 0, this integral we are going to call it as beta function, beta m comma n. What is this m from? ये m कहाँबाट आयो? यो m यहाँ appear भयो. Okay, यो n कुन चाहिँ हो? This n. Okay, so what does it mean? Suppose we have in place of m we have let's say 4 minus 1 and this is 5 minus 1. Okay, n को ठाउँमा 5, m को ठाउँमा 4 भयो नि, it means you are talking about beta 4 comma 5 and so on. Clear? Now let's look at another integral. So another integral, your integral is improper integral. Do you notice this? अनि तिमीको some standard improper integral मा पनि same function छ. You just go through it. It's gamma function, one of the some standard improper integral. I have already mentioned that there are certain improper integrals which you will be studying later. So this is one of the integral. And your function, limits of integration is 0 to infinity, and your function is e to the power minus of x to the power n minus 1 dx. This is your gamma function. Okay, and यसलाई you can see what is written here. This symbol represents gamma function. Okay, so तिमीको यो जुन L छ, L लाई hang गरिदियो भने you will get gamma function. Okay, so तिमीको symbol, this is your symbol. Don't introduce this. If you add extra decoration, it will become something else. What is this? Square root, isn't it? So don't make it square root. This is just this much. All right, so this is your gamma function. Now where does this n comes from? What is this n? This n comes from power of x. Okay, x to the power n minus 1. So what does it mean? 0 to the power infinity, e to the power minus x, x to the power 3x, dx is gamma what? Can you tell me?
Gamma 2.
Very good, gamma 2. Because you can write this. You can write this as 2 minus 1. I know. Sorry, 4. What am I doing? I was going with the flow. You gave me wrong answer and I was going with your answer. Okay, so it's 4 minus 1.
Sorry, ma'am. Sorry, ma'am.
It's okay. It's okay. So you will get gamma 4 here. Gamma 4. So on. I know what is your n. अब तिमीको यहाँ 1/2 पनि हुन सक्छ and so on. Okay, so it depends. What is the condition? You can see here also your n must be greater than 0. तिमीको gamma function भित्र जुन पनि value छ gamma, it always takes greater than 0 values. Okay, non-negative ra 0 value lidaina. That's a gamma function. Now I'm sure difficult, you might face difficulty, you might think it's slightly complicated, but I guarantee you when we will be doing the exercises, you will find it very interesting, most easy. Okay, so you don't need to panic right now. Do not panic right now. Okay, so let's begin with this. Hamro whole exercise, coming exercise from beta gamma function depends on its properties. Hamro beta gamma function ko properties ma depends garcha. Okay, so let's look at few properties today, because we won't be able, time is not sufficient, we won't be able to discuss all the properties. So let's just discuss few of them. Let's look at this first property. What do you see? Do you see any change in both the expressions?
China, ma'am.
China, but let me make one changes. We can make one change. What is that change? What I have done? I have interchanged value of n and m. Okay, so first property says your beta m comma n is equals to beta n comma m. Okay, so your m and n can be interchanged. So look at integral right now. Your property कसरी prove हुन्छ, we have to go back to its integral हेर्न साथ हामीलाई थाहा हुन्छ. Okay, look at this integral and tell me यो m र n को value interchange गर्नु मिल्छ र? Can we interchange this value of m and n? Why property says this? Property ले यस्तो किन भन्यो? Just tell me, what is the reason behind it?
किनभनेपछि मिलिहाल्छ नि.
1 ले यतापट्टि माइनस गर्दिने के त्यो सुरुमा पढेको रुल जस्तै.
Property of definite integral. Just say properties of definite integral, isn't it? Yes. Okay. Yes. So you see, apply properties of definite integral. When you apply property number 4, again your 3-star property, I know. हमले त्यसलाई 3-star किन देते हैं? Because I have already mentioned that we are going to use this property again and again and again. Okay. So we are using second time in this today's lecture. Okay. So you see, it's very important. So here also, wherever there is x, just replace it by 1 minus x. So when you do that, after using property, how your integral changes? 0 to 1, x will be replaced by 1 minus x to the power m minus 1. And 1 minus x ko ठाउँमा जहाँ x la 1 minus x राख्यो, again you will get this 1 minus x ma x la 1 minus x राख्दाखेरि you will again get only x here. So x to the power n minus 1 dx. So you see, x minus 1 minus x ka power n minus 1 छ, यहाँ चाहिँ 1 minus x ka power m minus 1. So m र n interchange भयो. That's the reason we can your first property says so. Okay, so your m and n can be interchanged. यसमा कसैले doubt? Look at property number 2. It says value of gamma 1 is equal to 1. How can you say so? What is gamma 1? Again, let's look at gamma function. Gamma function. Look at gamma function. What is gamma 1? 1 means wherever there is n in this integral, replace it by 1. So what will you get? You will get e to the power minus x dx, only because x ka power 1 minus 1 bhayo, so it becomes 1 e to the power minus x. Now what is integration of e to the power minus x?
Minus e to the power minus x.
Very good.
0
to your limits. Okay, I haven't applied concept of limits here. Limit, what will you do? Ali lengthy hai short ma explain matra garna khojega. You can apply limit b tends to infinity, 0 to b, you can take it. Okay, so now What will you get when you put x equals to infinity? Upper limit gives you
0.
yes, upper limit gives you 0. What about lower limit?
+1.
Yes, this 0, e to the power 0 gives you 1. Okay, so finally your value is 1. That's why you have got gamma 1 equals 1. Okay, so any doubt in this? Now let's look at another property. Observe this property. What does it says? It says value of gamma n plus 1 is equals to n gamma n. Okay, so तिमीको यसपछि क्लास खाली छ?
छैन म्याम।
Okay.
आज एउटा पनि छैन।
Gamma n plus 1. So it means gamma n plus 1 is यहाँ n को ठाउँमा n plus 1 राखौँ न हैन? So what will you get? So let's use this expression here. Gamma n plus 1 भनेको x को पावरमा n minus 1 को ठाउँमा n मा n plus 1 आइसकेपछि what will you get? Okay, you see यहाँ gamma n हुँदाखेरि n minus 1 थियो, gamma n plus 1 भनेको यहाँ gamma x to the power n भएन? So it's simply x to the power n dx. Now you have to integrate this. For integration, you have to apply integration by parts. Which function will be your first function? Eilert rule. Use Eilert rule.
x
to power n like first function राख्नु।
I know. Okay. So let's do this. Let's integrate this. Okay. So what are we going to get? So you are going to get first function as it is. Integration of second will give you this. I'm not applying limits of integration right now. Okay, just let's just simplify our expression. Minus of whole integration of differentiation of first भनेको यसको differentiation. So you will get n x to the power n minus 1 and integration of second will give you, let me do it this way, minus x dx. Okay, so we will get this. Finally, let's apply limits of integration in both the expression. So you have to apply limits of integration here also. 0 to infinity, minus becomes plus, n is constant, let's take it outside. Integration from 0 to infinity, yes?
यो त obvious नै भइसक्यो अब त।
के भइसक्यो?
मतलब अब त थाहा भइहाल्यो यो त भइहाल्छ भन्ने। यहाँपछि
यसपछि त के गर्नै परेन। What expression you are going to get from first one? What value you are going to get from first one?
0
आउँछ. When you put infinity, you will get one of the term will make it as 0, that is e to the power minus infinity. यसले गर्दा फेरि infinity राख्दाखेरि 0 आउँछ अनि 0 राख्दाखेरि यसले गर्दा 0 आउँछ. Okay, although you cannot directly put 0 here, किन infinity राख्दा फेरि you will get infinity into 0, but you will apply L'Hopital's rule here. मैले यहाँ lengthy बनाउन खोजेन. You do one thing, you go through some standard improper integral जुन exercise छ त्यसमा अब यो हामीले question sort out गरिसक्यो. Now when you go through it, you will understand the process. Okay, you can go through it now. I mean after this lecture. All right, so what is this? What is this? N into this is your exactly in, isn't it? So you got n times of in, not in, sorry, gamma n. gamma n. N times of gamma n. So hence you got gamma n plus 1 equals n times of gamma n. All right, one last property. Let's just quickly look at it because it follows this one. इसे को follow कर रहा अर्को property बने. Okay, so there is one special condition. ये जो property number 3 था, if we apply a special condition to this property, we will get property number 4. So what does this says? Property number 4 says gamma n plus 1 is equals to n factorial. The symbol, I hope all of you recognize n factorial. Okay. So if n is positive integer, only in that case. So let me give you example. If we say gamma 5, use property number 3. We have just seen that what is gamma 5? Gamma 5 is 4 gamma 4. Yes or no? What does this property says? Gamma n plus 1 equals n gamma n. So gamma 5 is equals to 4 gamma 4. Now we are not going to leave it here. What is gamma 4?
Gamma 4 equals 3
gamma 3. Now again, carry on.
2 gamma
4 into 3 into 2 gamma 2. Now what is 2 gamma 2? 4 into 3 into 2 into 1 gamma 1. What is gamma 1?
Gamma 1 is 1.
1. Property number 2. Okay, so your gamma 1 is 1 using property number 2. Okay, so hence you got 5 gamma 5 equals to 4 factorial.
Yes, ma'am.
Right? Gamma 5 is equals to 4 factorial because 5 is positive integer. Okay, तिमीको यहाँ 7 भएको भए you could have got 6 factorial. यहाँ तिमीको 8 भएको भए 7 factorial and so on. So you see this gamma function is related to factorials. तिमीको जुन gamma function छ, it is generalized form of your factorials. तिमीहरुले जुन factorials अहिलेसम्म use गरे, that factorials were for only positive integer, हैन? तिमीले 5 4 6 7 8 छ भने तिमीले gamma function use गर्न factorials use गर्छ. What if you have 11 by 2? What about its factorial? Okay, so whenever we have such type of number, their factorials is represented by gamma function. So that's the relation. That's the relation between factorials and gamma function. That is why your gamma function is very important. अब तिमीले future studies गर्दा फेरि you will be dealing with gamma function. Okay? तिमीको probability मा पनि Yes, what are you saying?
Ma'am, अब हामी अरु क्लासमा जानुपर्छ. हामी 5 मिनेट जति लेट भइसक्यो.
Yes, I'm about to conclude. Okay, so that's the end. I've already mentioned that this will be the final property which we will be discussing. Yes, any doubts to anyone? Anything that needs to be repeated?